Okay, so today we are going to start with our chapter 5. It is talking about integration, and then in my opinion, right, this chapter actually is quite tough, and then because there are a lot of techniques and also a lot of rules, integration rules that you need to know when you want to apply it in the question, in the past year exam question. All right, so usually students, most of the time, students actually cannot manage to understand this whole chapter properly. So if let's say you really want to understand, actually it needs times, and also most of the time, right, it needs you to apply all the knowledge that you learned previously in chapter 1 until 4. Although this is integration, but you will see that when you want to solve the solution, you need a lot of extra information or maybe a lot of extra knowledge from other chapters to help you to complete the whole question. Okay, right, so let's start with our basic integration first, right? Okay, so generally, if you look at the learning outcome, you need to integrate a few basic type of the function. As an example, you need to learn how to integrate e power ax plus b, how to integrate 1 over ax plus b, how to integrate 1 over x squared plus a squared, and also how to integrate these three trigo. All these are basic. Basic means that no need extra steps. Generally, it's quite straightforward, and then there's no extra techniques needed. All right, so you just apply it according to the rules that you learn. So all these are basic one, basic integration. After that, when you proceed further, then you will see that there are some questions you need to apply trigo identities before you can do the integration. And then if you go further again, there are some certain patterns, right? You need to apply some certain techniques, okay, to get the integration. So that's why it makes this whole chapter very complicated. Right? Okay, so let's start with the basic integration first. Okay, so first of all, we are going to learn how to integrate the exponential and also the log. Okay, so wait. All right, so how to integrate the exponential and log. Okay, so generally, what do we have is, okay, you just need to remember, try to recall back. All right, in differentiation, do you still remember how we differentiate log x? Okay, so when you want to differentiate log x, you bring the x, the thing inside the bracket down, right, become denominator, and then you differentiate the x, you get a 1. So you're having 1 over x. Correct or not? And also the same thing happens if let's say you're having log ax plus b. Okay, how you do the differentiation for log ax plus b? So if you apply log ax plus b, you bring the whole bracket down, ax plus b, and after that you differentiate the ax plus b, you get an a, so you put an a on top. So this is why we have it for differentiation. And then integration means you need to do it the other way around. So that means now you want to integrate 1 over x, then you should get back log x. Okay, so here the very first equation that you need to know, integrate 1 over x is equals to log x. Okay, so maybe you'll ask me, hey, can I do something that you learned before, like 1 over x, right, is actually x power negative 1. So can I take the power plus 1, then divided by new power or not? So if you try negative 1 plus 1, so negative 1 plus 1 becomes 0, right? So you'll see that you cannot apply the method that you learned before in AS level here, because you'll get something divided by 0, which is a math error. All right, therefore, when you want to integrate 1 over x, it is a special rules. You will have the log x. Okay, so you try to think a way to memorize it. Okay, so when we want to integrate it, you have to know that log, the thing inside the log must be always positive so that it is defined. So usually they'll put it as a modulus x. Okay, but for me, throughout this whole session, right, when I try to explain it, or maybe when I try to show you the answer, I usually write a bracket. But myself, I actually understand that this value should be a positive value, so which is a modulus. Okay, so I didn't write a modulus, but you should know that it should be a modulus, all right? Okay, so this is the first one. And after that, when you want to integrate, if you want to integrate a over ax plus b, then you should get log ax plus b. But now the problem now is, if let's say I don't want to integrate the a, I only have a 1 here. So the a, you can move it over, and therefore you're having 1 over a ln ax plus b. If you want to integrate ax plus b. Okay, so the second rules that you need to know is when you want to integrate 1 over ax plus b, then you should have 1 over a ln ax plus b. Or you can think it like this, integrate 1 over ax plus b, you bring the ax plus b up, become ln ax plus b, and you differentiate the ax plus b is a, right? You divide it by a. For differentiation, you multiply. For integration, you divide it also can. All right, so these are some basic rules on integration of 1 over x and also 1 over ax plus b. Okay, so I might show you some example here, some very simple example to make sure that you roughly know like what happened. Okay, so as an example, if let's say I want you to integrate 1 over 2x. Okay, so when I want to integrate 1 over 2x, I will take out the 2 because the 1 over 2 is a constant, so I just integrate the 1 over x. Therefore, I will have 1 over 2 ln x, then plus c. Okay, and then some student will ask me, hey, can I do it the other way or not? If let's say I'm having 1 over 2x, I will take the whole thing up, become ln 2x. Okay, and then I divided it by, I differentiate the 2x, I get a 2. So divided by 2. Can or not? This also can. So for this question itself, you have two ways of answering. The answer is the same actually. Alright, just that for me, I prefer to use this method because generally when I pull out the constant, right, only I apply the integration, my solution will not look so complicated. Okay, so this is what you should know about it. Alright, so let's continue for the other one. Okay, how about if let's say I'm having this, let's say I'm having 3 over 5x plus 2. Okay, so if I want to integrate this, usually what I'm going to do is I will take out the 3 first because 3 is a constant. So I integrate 1 over 5x plus 2. So when I want to integrate 1 over 5x plus 2, okay, generally what I need to do is like I just copy the 3, I'm having ln, then 5x plus 2 divided by the differentiation of 5x plus 2. So differentiation of 5 plus 2, you get a 5. So when you try to simplify, you have 3 over 5 ln 5x plus 2 and then plus. Can you understand? Alright, so this is something quite basic and then I hope that you actually know how to do it. Okay? Alright, so we try a few more. Some basic one first before I let you try the example yourself. Okay, so how about if let's say I want you to do the integration like this. Okay, if I'm having this. Okay, so if let's say I'm having 2 divided by x squared. Okay, so 2 is a constant, I just take it out, 1 over x squared. Alright, so can I have it like 2 and I bring the x squared up, become ln x squared, and then divide by the differentiation of x squared, then I have 2x, then plus c. And after that, I'm having ln x squared divided by x, then plus c. Okay, so if you look at the method here, when I'm having 2 over x squared, alright, so, and I try to apply the method that we learned just now and try to simplify, this is the answer that I get. If you are applying this method in this kind of question, the answer is wrong. Okay, the correct way should be what? Okay, so the correct way to integrate this one is actually, you should pull out the 2, because 2 is a constant, and then after that, you have x power negative 2, and to do the integration for this, x power negative 2, you are doing it as power plus 1. So negative 2 plus 1, you get negative 1 divided by the new power, then plus c. So eventually you are having negative 2 over x plus c. So this is something that you should have. This is the correct method and this is the wrong method. So what I want to tell you here is actually when we start to learn all these basic or extra patterns of the integration, a lot of students, they will apply the wrong method. Okay, so for this method, when you want to change it become ln, there's one rule here that you need to know. It must be only applicable for x power 1. Cannot be any other power. If let's say you're having any other power here, then generally you have to apply the method that you learned in AS level before. Okay, alright, so this is only applicable for x power 1 only, not other function. Okay, so for integration, when you apply all the rules here, it is very strict one. You have to look at the pattern very carefully. Okay, so if let's say 1 over x when integrate is like this, but it doesn't mean the same for 2 over x squared. So for 2 over x squared, apply AS method. Okay, alright, so you don't tell me that, hey, the pattern look almost the same, so I can apply the same method, cannot. So you have to be very clear for what kind of pattern you have to apply what kind of rules. Alright, okay, so maybe you try another one. How about if let's say I tell you I'm having this, let's say I want you to integrate 1 over x squared plus 2, let's say. Okay, so some student will tell me, oh, okay, 1 over x squared plus 2, I take it out, become ln x squared plus 2. And then I divided by the differentiation of the x squared plus 2. So I got 2x, then plus c. So again, if you are having this as your answer, this is wrong. Although it looks very logic because it is something like you learned just now, right? But again, this is wrong. How to integrate the function for this one correctly, we will learn other method later. Okay, it actually belongs to other technique or other methods one. So you cannot apply the technique that we learned here. Why? Because for this pattern, if you want to bring it become ln ax plus b divided by 1 divided by a, the rules that you follow here is the pattern is the whole bracket here must be power 1 only, and inside the bracket must be only x power 1. If let's say inside the bracket for x power 2, x power 3 or whatsoever, you cannot apply it. If the power outside also, okay, is other power, you also cannot apply this method. Alright, okay, so maybe I take another example. If let's say I'm having 1 over 2x minus 3 power 4, let's say. So you also cannot tell me that, oh, I bring up the bracket become ln 2x minus 3 power 4, cannot. Okay, so what should you do is, you have to apply the technique that you learned in AS level before. Okay, so how you apply it? So the power plus 1 become negative 3 divided by negative 3. Differentiate the thing inside the bracket, you get a 2. So this is the correct way. Can see that or not? So again, when you want to apply these two rules here, you make sure that your question actually follow the pattern that we have, which is x power 1. Then here also x power 1, and then the whole bracket power 1. Only, no other power. Alright, so please make sure that you remember this. Okay? Alright, so if no problem, then just try out the example 1, part A, part B, and part C. Please pause the video here, try out these 3 questions first, and then only you come back and check your answer. Alright, so I should really give the answer here. So for part 1, this is the answer. Okay, so for part 2, and then for part 3. Okay, so these 3 questions here is very basic, just to test your understanding only. Alright, okay, so let's continue to example 2. In example 2, they slightly talk about the integration, application of the integration. Okay, so here they want you to find the exact value of the constant k when they give you this information. Alright, so this is the information that they give you, and when you try to start from here, you should be able to solve for the k. Alright, so we will start now. They want you to integrate from 1 until k for 1 over 2x minus 1. And it is equals to 1. Okay, so if you look at this integration, generally what you have is you are having ln 2x minus 1 divided by 2. And you let it equals to 1. Okay, so again, before I substitute the value of k and value of 1 inside my equation, I usually prefer to take out constant so that my steps doesn't look so complicated with the fraction inside. Okay, so I'm having k1 equals to 1. Alright, so if you look at this one, I'm having ln 2k minus 1. Okay, then minus ln 1, and then equals to 2. I bring the half over, become multiply with 2 first. Let's substitute the 1 inside. Okay, so you should know that what is the value for ln 1. So if you already forget, ln 1 should be equals to 0. So this knowledge is from chapter 2. Okay, so if you continue next, then what do you have here is you're having ln 2k minus 1 equals to 2. So they want exact value, right? Okay, so now I want to get the value of k, therefore I have to move the ln over. How can I move the ln over? Ln is base e, correct or not? Therefore, if you bring the ln over, you have 2k minus 1 equals to e power 2. Again, how you change this one, you need the knowledge from chapter 2. Okay, when you learn how to bring the ln over and so on. So all these are from chapter 2. Okay, all right. After that, you try to get the value of k. So to get the value of k, you are having x squared plus 1 and divided by 2. So this is your answer. So again, when you're trying to solve this kind of question, besides the integration technique that you learned just now, you also need to have the knowledge in chapter 2, how to move the ln over, how to simplify all the equation and so on. All right, so this is why you have it for example 2. Okay, so I hope that you understand how we do it. All right, so again, all this basic one, it is not enough for you to solve partial question yet. All right, but you learn all the basic first slowly, and then after that only you try out the partial question. Okay, then let us continue to the next part. Next part, we are going to learn how to do the integration for e. Okay, when you integrate e power x, straight away you will get e power x, and you just copy the same thing. Okay, so it is actually very similar to what we learned in differentiation, because when you differentiate e power x, you get back the e power x, right? Okay, so it's the same actually according to our differentiation rules. Okay, then now how about if I say I want to integrate e power ax plus b? So if you want to do the e power ax plus b, generally you copy back the question also, e power ax plus b. You differentiate power, then you divide it by the differentiation of the power. So you divide it by a. For differentiation, we multiply it. You multiply by a. But for integration, you divide it by a. So it is the opposite process or opposite sequence, right? Okay, so for the third part, we no need to know about it because it is kind of confusing. So we will learn this later. Okay, maybe in some other parts of the question. All right, so we'll focus on these two only. Okay, so as an example, if let's say I'm having e power 2x, what do you get when you want to integrate e power 2x? So again, you copy back the original thing. Differentiate the power is the 2, right? So you divide it by 2. So plus c. Okay, so this is how you integrate it. Okay, if let's say you're having 1 or maybe 3, 3 over e power 4x. So how can you do this integration? So first I take out the 3 and then I bring it become e power negative 4x. Okay, so when I want to integrate e power negative 4x, I copy back the original thing. And then I divided by the differentiation of the power. So differentiation of the power means negative 4. So you just put in negative 4 here. And then plus c. Okay, so if you try to simplify, you're having negative 3 over 4 e negative 4x plus c. Okay, so this is how we do the differentiation for exponential function. It is not hard actually. Okay, all right. So the same thing happened when you want to apply the rule, this basic integration and exponential function. Please double check for your power here. The power must be x power 1 only. Cannot be any other power. Cannot be power 2, power 3, power 4, and so on. Right? And then for the same thing happen here for part B, the factor must be ax power 1 only with the bracket power 1. Okay, so as an example, if let's say I tell you that I'm having e power x squared, how can you do the integration? So you cannot tell me that, oh, teacher, I apply the rules, which is copy back the original thing, and then I differentiate x squared, I got 2x, then plus c. This is wrong, because it didn't fulfill the rules that we have here. So this rule basically only applicable for x power 1. Okay, so the same thing happened for this. Okay, so as an example, if I'm having e x power 3 minus 2, so can you do the same thing like what I showed you just now? Cannot. So how to integrate all this? We might learn some other methods in the future. All right, but it is not for now, so you cannot integrate all this yet. Okay, so again, please make sure that you are aware of the rule here must be always power 1 only, no other power accepted. Okay, all right. So again, the same thing. Please pause the video first, complete example 3, and then you come back for the answer. All right. So for example 3, the answer is this. Example 3b. Example 3c. This is 2. Okay, and also example D. So all these integration are very basic, just to make sure that you know how to do the basic integration only. All right. Okay, then again we can have a look for example 4. So the same thing happened like last time. When you learn all this technique, right, they will also test you for the application part. Okay, so when you look at the application part, again, you need to apply the knowledge that you learned in AS level before. So AS level, like you learn how to find the maximum, minimum point, and all those things, right? You just follow exactly what you learned before. Okay, all right. So let's have a look for example 4 here together. I'm having this curve, and they tell me that the maximum point is M. So the x coordinate of M is denoted by P. All right. So first they want to find the x value of P. Okay. So again, you want to find out the x coordinate for maximum point. Okay, so what is the x coordinate for maximum point? First, you need to do the differentiation. Okay, not integration and differentiation. So please don't confuse of it. All right, this is maximum point, so differentiation first. Okay, differentiate e power negative x, you get negative e negative x. When you differentiate this one, you have plus 2e negative 2x. So again, please make sure that you go and revise a bit about the differentiation if you already forget how to do it correctly. Okay, so to find the x coordinate for maximum point, you let dy dx equals to 0. And this is what you have here. All right, so you try to get the value for x. Okay, so to get the value of x, I try to move everything over. Then I'm having something like this. I'm having 2 over e power 2x equals to 1 over ex. So if I bring e power 2x over, I will have e power 2x ex equals to 2. Then I'm having ex equals to 2. Okay, and then after that, how can I get the value of x? Both sides I take ln, therefore x equals to ln 2, and that's why p is equals to ln 2. P is the x coordinate of the maximum point. Okay, so I will just keep it as ln 2 because the word exact value. So they don't want to have any decimal number on the long decimal number. So they want you to keep it in exact value. Okay, so this is how we solve the first part. So this is differentiation, something that you learned in the previous chapter. Alright. Okay, then next, for part number 2, they want you to show that the area, okay, of the shaded region bounded by the curve, the x-axis and the line equals to P is equals to 1 over 8. So now they actually want you to prove that the area under the graph for this one, answer is 1 over 8. Okay, so under the graph means that you need to do integration. All right, so let's start with the integration part. Okay, so how can we apply the integration knowledge and apply it here? Okay, so to get the area under the graph, okay, so this area mainly covered by x-axis, right? So usually I prefer to use dy. So integrate e power negative x minus e power negative 2x. And then what's the value that I have to put in here? So the x value area start from here, which is a 0, and then end at here, which is the p. P is ln 2. Therefore, when you put in the limit from 0 until ln 2. Okay, how you do the integration for e negative x? So I'm having e negative x divided by negative 1 minus, I copy e negative 2x divided by negative 2. Then I need to put in the value of ln 2 and also 0. Again, before I do any thing here, I will try to simplify everything. if I simplify the whole thing here, right, I'm having 1 over 2e 2x, okay, minus 1 over e power x. I try to simplify the thing inside the bracket, and I don't like all the negative sign here because it will make my steps look complicated later. So I just try to simplify as much as I can, and then only I put in the value for ln 2 and 0. Okay, so if I put in ln 2, what do I have here? I'm having 1 over 2 e 2 ln 2. Okay, then minus 1 over e ln 2. Then minus again. Now you want to substitute the value of 0 into the e power x. So you're having 1 over 2 because e power 0 is 1. It's not 0, so don't assume whole thing is 0. So when you substitute 0 into e power 2x, you have e power 0. So e power 0 is what? Is a 1. So you're having 1 over 2 here, then minus 1. Okay, so if you continue further, okay, let's have a look for this one. Alright, so what is the value for e power 2 ln 2? Okay, so e power 2 ln 2, you can write it become e ln 4 because the 2 you can bring it back. So become 2 squared is a 4. So press calculator e ln 4, you'll get a 4. Okay, so if you get a 4 here, that means when you simplify it with the 2, so you have 1 over 8 minus 1 over 2, okay, then minus 1 over 2 minus 1. Okay, so this is what we have, and after that, if you try to simplify everything, then you can get the 1 over 8 very easily. Alright, so again, what are the techniques that you need here? You need some knowledge in chapter 2 also, like when they talk about e power something, e power ln something. Okay, so this is how we do it, or we deal with the application question for integration. Alright, so now you learn 2 basic integration already for A2 syllabus. The first one is how to integrate 1 over x and also 1 over ax plus b. Then the second one is how you integrate e power something with x power 1. Okay, so this is what we have here, and then if can, you try to you try out all the small topic, the exercise for the small topics, so that you're familiar with all the integration. Once you practice enough, then generally when you look at the question next time, right, it will be quite easy for you. Alright, so we'll stop here for this video, and we will continue with the next basic integration in the next video.